So, hello everybody. We are ready for our next masterclass. Our guest is Divya Mohan from SUSE, and she is going to speak to you about Kubernetes right from out of her workplace in Mumbai. So, let's head over to Divya.
Divya, just wait for a moment. You need to restart. Yeah, you're online.
All right. So thank you so much, Eric, for that introduction. And hello, everyone. I am Divya Mohan, and I'm just going to start my screen sharing so that there's no lag here. Um, um, Hopefully, you're able to see my screen right now with my photo and the rest of the stuff. Please, can someone confirm if that's okay? All right. So as Eric mentioned, I do work with SUSE, which is one of the Linux companies alongside Red Hat. We both work in the open source ecosystem, and in at SUSE, I'm a principal technology advocate, which means that I help build the technical community around SUSE's projects, whether they be in the cloud native or the Kubernetes space, or in the edge domain, or even in the Linux space. But contextual to today's presentation or session, I think it's important to mention that I'm one of the maintainers of the Kubernetes project, and one of the community co-chairs for the WebAssembly ecosystem under the Bytecode Alliance, as well as the lead for the Chaos project, the Asia chapter of the Chaos project, which deals with building community health and community health metrics around open source projects. So in the internet, rather on the internet, you can find me on LinkedIn and on Blue Sky. And I'm also fairly active on my blog as well. I've not updated it in a while this year, but I am fairly active on my blog. So these are good places to reach out to me. But as Eric mentioned, today we're talking about mastering Kubernetes fundamentals for your cloud native success. Now, um, I understand that a lot of y'all might not have heard of Kubernetes or even the term cloud native. And even if you have, it's great. We are going to have a refresher of sorts. And we're going to do that in a very accessible context. And we're going to do that with the help of the example of a very average programmer, just like you, me, or anyone else watching the stream. For the sake of the session, I'm going to call him Joe, and Joe is going to be your developer or a coder working in a company known as Lorem Company. Now, his company, as a matter of fact, has asked him to develop a web application and use that and his company basically wants to use that application to sort of record member thoughts about their company. So basically sort of like a guest book web application. And Joe has been given all the freedom of choice in the kind of language he should be using, the kind of platform he should be deploying it on, the technology, the framework. Joe and his team have complete autonomy in that. But that autonomy also brings a sort of confusion, and it brings a lot of choices that need to be made, because imagine uh, thinking about so many things. What language do I write the application in? What front end framework do I use? Where do I deploy it? What platform should it be servicing? So there are so many questions, and I'm sure, I don't even need to tell everyone here the frustrations of slowly loading web pages. Everyone's familiar with that. So obviously, when the actual application does go live and people in question are able to access the website, um, if it is not up and running in a proper manner, or if it's not able to have adequate amount of resources and adequate amount of memory or whatever assigned to it, it will not serve the users that it's supposed to serve. um, but what has all of this got to do with Kubernetes, and why am I talking about all of this? It's because Kubernetes actually does help in automating a lot of these things that I just spoke about, whether it is actually installing the application, or whether it is scaling the application based on your user demand or based on any other parameter, and also management of the application itself. So I know that all of you can see a red word here, which is containerized. And all of y'all really must be thinking, why? What is this containerized thing? So containerization is a sort of an abstraction. Now, abstraction in its very fundamental definition is the process of removing any unnecessary details from something so that you can actually focus on what's essential. Now, why does containerization pertain to abstraction, and why is it considered as a form of abstraction, is what we're going to understand in the next couple of minutes. So let's do that with the help of our buddy Joe again. Now, we spoke about all the myriad choices that he had. He had to choose the language, the platform, the technology, the framework, etc., etc., etc. But I'm not sure about how many of us here have actually seen a server rack at a data center. Very few of us have actually worked with server racks and actually physically seen a server rack in operation. Most of us don't even know that such things exist because of the use of things like cloud and cloud native. We've heard of these terms, but we've not really seen data center server racks in operation. And why is that the case? Because it has been carefully abstracted away for us. So when you think about servers and server racks, you don't actually think of them as somebody actually operating them in some remote part of the world. But they do require operation. They do require costs to maintain them. And honestly speaking, not a lot of us know how to work with them. I'm sure not a lot of us know assembly level program. And uh, and that is precisely because we as a collective within not just the open source space but the IT ecosystem have developed layers and layers of abstraction to hide away all of these unnecessary details, and have developers focus on what they do best, which is writing code. So the very first layer of abstraction that we came up with so that we don't have to interact with servers directly is that of the operating system. And the operating system, as you all probably know and already work with, there's tons of them out there, different flavors, and basically it's like an interface that allows you to communicate with with your computer or your laptop or the server in question, and have it understand what you are telling it and do the necessary things and give you an output. But imagine if we were to deploy or use one particular server or laptop or computer only for one application. You're assigned a particular amount of memory and CPU, and beyond that, you don't get anything. And imagine the number of computers it would take, given the number of apps that we have today, both mobile and all your desktop apps, everything taken into consideration. Imagine the number of servers that we would need today. I'm pretty sure, given that context, we would be thinking of how do we use resources within existing computers, servers, laptops better, and how we sort of like um, avoid the wastage. So that is where the concept of virtualization, which is another layer of abstraction, comes in. We've introduced the concept of virtual machines through the use of a hypervisor, and so far so good. because we have like the entire machine being utilized, and each of the virtual machines being separate from one another. So you are able to get an efficient utilization of the resources. You're able to ensure that one virtual machine does not talk to another virtual machine and sneak into its data or whatever. And that being said, Joe also is very happy in this case. So he's like, "Yay, virtual machines, great." But say at some point in time, some team within the company, other team within the company wants to take Joe's application and customize it, or it's not for external use; it's for internal use. So there are several parameters that you need to change, and they want to basically customize it. Now they are they are looking at a totally different sort of framework and technology, and packaging and everything that comes with Joe is not that Joe has done is not compatible with the one that the other team is looking at. So there's obviously a distribution and a supply chain problem here, which is why containers were introduced. Not these are shipping containers, by the way. If you'll have seen shipping containers, and you must wonder why are there these colorful looking containers on top of a ship. They were introduced by Malcolm McLean. I don't remember the date, but I'm thinking it's probably in the 1800s. But they were introduced because Malcolm noticed that um, in transiting goods and materials from one place to another, the amount of space that was being used on a ship or whatever other transportation mechanism, it was not being used very efficiently. That was because, as everybody here knows, goods and any sort of items that are man-made or even natural, they occupy different amounts of space. And given that if we try to push all of them in a limited amount of space, they're not really going to fit the same way. So to standardize the way containers were introduced, and to standardize the way these things were shipped. And these containers are the reasons that you have things like Amazon Prime delivery and one day or less than one day delivery available today, because these are what make these are what um, these are the reason basically behind making the supply chain as efficient as it is today. So similar to that, in technology also we have the concept of a container. Now, this is a very high level overview of what a container looks like, and given how the same thing was achieved in given how the standardization and efficiency was achieved in the shipping industry and the transportation industry, we to some extent achieved this with containerization in the recent I think 15 20 years. But again, why are we talking about Kubernetes? We've still not started as to why we're wondering where does Kubernetes fit in, and why is only Kubernetes being talked about? Because surely managing containers is not that much of a task if it's just maybe 10 or 15. But at scale, um, aren't there other tools that can manage them? And weren't there predecessors to Kubernetes that could manage them? Yes, there were and there are. The reason why Kubernetes sort of broke out as a phenomenon was because of its extensive and impressive capabilities to ensure the seamless orchestration of the containers in the seamless orchestration of containers basically. So how does it achieve this? And we're going to look at all of the basic concepts in different rounds. So first round, we're going to look at a concept called as node. Now, a lot of you must already know this, but a node is basically just a machine. It could be a actual physical machine like a laptop or a server, but it could also be a virtual one because, as we saw before, there are virtual machines in existence. And having worked extensively with virtual machines myself, and having all Kubernetes installations atop virtual machines in my previous job, I can confirm that both virtual and physical machines qualify as nodes. And according to the physical, not according to the physical, according to the Kubernetes documentation, this is an actual depiction of a node. Don't go by the drawing. This is kind of what a node comprises of. And here we can see that it contains of a containerized app. But there's a bubble around that containerized app, and it is called as a pod. So does that mean there is something else known as a pod? And yes, there is. That's the second concept that we are talking about today. Pods are basically very similar to how you would assume green peas in one single pod, or you would think about whales in a pod. Now, I didn't have a better photo of whales here, so I'm sorry. But when you think about green peas, a bunch of green peas in a single pod, or about a bunch of whales in a pod, you are thinking of a bunch of disparate units grouped together, right? In a similar way, even in Kubernetes, a pod basically groups together containers. But there is a caveat here. Per the best practices laid down by the Kubernetes project, although a pod can contain more than one container, it ideally shouldn't. And the stray case where it should is when the multiple containers are actually sharing some sort of resource like disk. And with the help of an example, that is our buddy Joe, I'm going to try to actually explain this to you. So assume that Joe has written his web application, yeah, and he has sort of containerized it, and it runs brilliantly on Kubernetes. We fast forwarded to the point where there's a problem, and we don't know where the problem lies. So what do we turn to? Logs. So logs or any sort of traces that we have are the first thing we look for when there's a problem. But unfortunately, Joe did not have a company logging included in his code, which means there are no application level logs. However, had he chosen to actually include the logging, that could have sort of been a sidecar container taking in all the application statistics and passing it to a central logging system where they could be analyzed, and potentially this problem could have been flagged earlier on before it became an actual problem. So there are very stray use cases where actual grouping of containers is recommended in a pod, but in general, the best practice for a pod is to have one container per pod. Now, again, like I said, um, Joe has done his deployment, and he kind of figured out without the logs that the amount of requests that were coming to the application server or the web server were the problem. So that means that there were lesser number of application. There were more number of requests coming in from user than the web server or the application server could handle. So what do we do in such a case? We scale. We sort of ensure that a number of copies are available to serve those application users so that they can actually access the application. But how do we do that in Kubernetes? And that's through deployments. This is our third concept for the day. And in um the word deployment itself, it comes from the French word deployer, which means to unfurl, spread out, deploy, or make copies of, in very simple terms. And that's what Joe is aiming to do, right? Make copies of his application so that those copies can actually serve requests. And according to the Kubernetes documentation, a deployment actually manages a set of pods to run an application workload. And it ensures that the state specified by Joe, say that, Joe has specified at any given point of time, two copies of the application need to be up. That actual state is maintained at any given point in time. And it does so through the help of deployment controller, and it does it with the help of another feedback loop that's known as the replication controller. And it's um, it's something we will see in the demo section later on. But again, um, imagine if some other team is also working on a completely different application within Joe's organization only, and you would assume that they would have to create a new cluster or a new Kubernetes node. Yeah, not necessarily. You would want to ensure optimum utilization of the resources that you have at hand instead of like just wasting money on newer resources every single time. That is where the concept of namespace in Kubernetes comes in. So namespace in Kubernetes provides a mechanism for isolating groups of resources within a single cluster. So this is per the Kubernetes documentation again, and this is very similar to something we heard just a couple of moments back. The isolation provided by virtual machines. Yeah, when we were talking about different virtual machines, sort of giving different, different sort of um, uh, isolation, not different sort of isolation, giving that isolation so that one app deployed in one virtual machine cannot really listen or understand what it is, what another app within another virtual machine is doing. That's the kind of thing that is talked about when we are talking about namespaces. So, in effect, if we use namespaces or if Joe's company uses namespaces, they can have different teams using the same cluster and using it more efficiently so that they can actually sort of, you know, avoid resource wastage and also save up on costs. And when we talk about namespaces, it's not like Kubernetes cluster itself does not come with a set of initial namespaces. So on creation of a Kubernetes cluster, you will have these four namespaces by default. I know there is one namespace here that is named default as well, but these four are available by default on creation of any Kubernetes cluster and any flavor of Kubernetes cluster, whether it's K3s, vanilla Kubernetes, K0s, whatever. These four namespaces are there no matter what. And they have different functions, and the reason why they're named the specific way is also because of the functions associated with them. You can read through the slide right now, but what I'm going to focus on is this specific namespace, which is kube node lease. And why I'm specifying this or highlighting this specific namespace is because it talks about node failure and heartbeats. So, who in the Kubernetes world decides what makes a node a failure? We haven't seen anything yet that is responsible for marking the node as a failure. Is it God? Is it someone else? Do we contact Amazon or whoever is responsible for your Kubernetes clusters on the cloud to understand if the node is a failure? No. So Kubernetes has a fourth concept, fundamental concept known as control plane. It's kind of like the brain of the entire uh, Kubernetes installation. And again, borrowing from the Kubernetes documentation, you can see what the typical Kubernetes cluster looks like. It has multiple nodes. It has a control plane on the left. Now, control plane, there are multiple components here, and we're going to go sort of one by one because all of it is very much to take in at the very first instance. So first up, we see the controller manager, and we spoke about controllers a while back. We spoke about deployment controllers and replication controllers, right? These are feedback loops that are there within the Kubernetes cluster that sort of ensure that a state is regulated. In Joe's case, it was to maintain two copies of his application up and running at any given point of time. So That is one example of how a controller functioning within the Kubernetes um, cluster. But you can also see when we're looking at the controller manager, there's an API box talking to that controller manager. Why is that the case? That's because the API server or Cube API server is that component within the control plane that actually takes in the user request to change or create new configuration and conveys it to the rest of the components within the control plane. Now, it's kind of like an interface between the outside world and the control plane. So when we think about changing or updating or even creating, that configuration needs to be stored somewhere. Where is that done? And that's where the persistent store comes in, which is HCD. It's a project within the CNCF ecosystem. It's also now taken inside the Kubernetes project because it's so crucial to storing cluster information, configs, secrets, etc. So HCD is where all of that information gets stored at within your Kubernetes cluster. And last but not the least, that's the scheduler. Now, scheduler is basically true to its name. It's responsible for scheduling your application on the various nodes. Now, you might not need every node taking in your application or serving your application, right? Or you might want a very specific node within your cluster serving your application based on some resource requirements or some user preferences. The scheduler is the one that does that after receiving a directive from the Cube API server. So I know I've talked a lot here, and it's probably boring to listen to a person who's been going on for so long. So I'm going to actually dive into a demo. Now we're going to just inspect stuff because I have never trusted live demos to work. So if you do want to follow along on the demo, you can download by scanning this QR code. Firstly, the software that I'm using is Rancher Desktop, which is from SUSE. It's the company that I work with. It's free. It's open source, so no charges there. In fact, we welcome people to come and suggest improvements or contribute code to the project itself. So you can download the Rancher Desktop software. It comes packaged with a Kubernetes cluster, so you don't have to create a new one. And it's also packed with all the other nifty utilities like Helm, kubectl, etc., so that you can actually start you can start going at the speed of 100 once you actually download it. So that's the first thing. But again, I'm going to borrow an example from the Kubernetes documentation. You can scan the QR code that's right now on your screen to lead to that example because the example is that of the guestbook, which Joe was supposed to deploy. And it actually, I have it deployed on my laptop right now on the K3s cluster on Rancher Desktop in my laptop right now. And we're going to see, how the guestbook application looks like. But we're also going to run through some of the concepts. So if you want the step-by-step method of how to do that, that's available here. It includes all the container images, etc., and references to more concepts that we could not cover in this. So I'm going to switch screens for a bit and ask for confirmation from one of y'all if y'all can see my uh, sorry, you can see my terminal. Is it visible? I cannot hear or see any one of y'all, so if y'all could be a little audible, it would be great. Richard, Eric, are any one of you around that you can confirm? Yeah, that's the one. Yeah. So I'm just gonna execute the kubectl command, which is the way you interact with a Kubernetes cluster. Yeah. So if you see here, These are the things that I've deployed earlier this morning. And you can see pods, you can see the deployments, you can see replica sets, you can see services. So what I have done is essentially deployed a multi-tier web application, just as we were talking about Joe. We I deployed this on my laptop and got it work. So I basically I'm gonna walk you through what it looks like when you want to see more things on the more things or dig deeper into each of these aspects. So Rancher Desktop has this nifty button called as the cluster dashboard. Now I'm scoping it to only user namespaces because I want to just check my applications right now. So there's obviously one node because we don't have multiple nodes. It's just my laptop here. So we have one node, and the Rancher Desktop is deployed on this. But even within the Rancher Desktop, there is the Lima virtual machine that basically hosts my Kubernetes or K3s cluster. Now, there are a bunch of pods that I deployed, which you saw already. You can see the names of each of these pods. You can also see the image that was kind of used for getting these pods to go up and running. So these are the things that I was talking about. Like these are those standardized, packaged ways of transmitting information, so that you don't have to have different teams talking in different languages. You can use the same format to have to package the code that you're writing and make it available to different teams and ensure that they are able to use your code as well. Now if you click on one of these, you will see the container that was created. And as I mentioned before, it's obviously always recommended that you have one container per pod, unless you know we need things like logging or something else. And if you want to see the config of this, that is also possible. You can check a lot of stuff here. But enough about this. And what is so new about all of this? Are there any other things that you can show us? Which is, yeah, I do. So one of the things that I did want to show y'all is the namespaces bit. So if you see, like I mentioned a couple of minutes back, we do have four namespaces, and I've not bothered creating a new one because just very lazy. So you have four namespaces here, and in each namespace you can actually check what are the pods there. So if for example, um, sorry, not this. Get pods and default. You'll get the ones here. So all of these pods are deployed in the default namespace. What about the cube system? Are there any there? So we can just like go here and see if there are any pods in this one. So pods are not the only things that can be within a namespace. You can have services, you can have deployments, you can have replica sets, etc. So if you see here, again, there are several pods that are running, but there are also several that are completed. So this namespace also does have something worth of value. Now, next up, one of the other things that I did want to show you is if the same thing was actually visible on Rancher Desktop. Maybe people are not really comfortable using command line. Are you actually looking at some more of like a how can I use a GUI or a user interface to view this? Of course, you can do that. So if you look here, all the pods that we saw recently, like the Cube system namespace, all of them are grouped here as well, with their respective statuses, whether it's completed, whether it's running, all of that. And even the cluster information and stuff like daemon sets and jobs and deployments, for what it's worth, because all of the uh, All of these, the things that are deployments, are essentially uh, not packaged with a Kubernetes cluster. They are add-ons, so you have to actually deploy them. So this is something that we've deployed. These are the user ones that I have deployed as part of the application, and these are the ones that are part of the Kubernetes cluster as part of Rancher Desktop. So as you can see, Rancher Desktop sort of gives you that clear view of what's there within a particular cluster. There's bunch of other stuff to explore as well. Like you have the services bit, you have storage, bunch of stuff. I'll not go too deep into it in the interest of not confusing you all. But other couple of things that I'd like to show you is the container images that are there currently. Right. Again, with just a click of a button, you have the container images that have been used on the cluster, just on the main page. And the containers that are there within the Kubernetes namespace, you can just have a look at them from the main view itself. You don't need to go into the cluster dashboard. And in case nothing works, like you deploy something and something breaks, it happens also often, right? When you actually deploy something, it doesn't work at the first go. So you have things like resetting Kubernetes by deleting all workloads and configuration. And if you have, you know, uh, how do I say it nicely? If you have ruined things beyond measure, you can just factory reset all of Rancher Desktop's configurations by doing this. And Rancher Desktop on the next launch will start fresh and new for you to sort of restart your development on. So this is a bit about Ranch Desktop, but I'm more interested in showing you how the guestbook bit works. So I'm gonna go to the port forward bit. I'm gonna show you two ways of doing port forwarding here. One is through the port forward command, which is there here. I'm It's there on the screen right now in the browser, and if I do that here, this does port forward it efficiently. Now I'm gonna just hit the HTTP localhost directly from here. If you can see here, hi there is one of the messages I had entered. Then if you want to do hackathon 2025, that will come here. This is on a live stream. So this is a guest book, just like how Joe in our example was supposed to create. But this was one way of ensuring a port is forwarded. Another way is something I want to show you, and I hope it works today. So there's a port forwarding option here, and you can just directly click this. So Ranch Desktop is actually pretty nifty in more than one way. So I'm just going to do 8080 here. Instead of writing that entire command, you can just do here and see. Let's see if that works. Let's hope that works. Actually, hey, it worked again. So that means this actually does work. So that's a bit about the Rancher desktop aspect of it, and how we got our application to work. You can follow the entire steps. You can go through it by scanning the QR code. I can put it up in a bit. Just a second. But essentially, this is the long and short of my discussion today. I really hope that you were able to gain some knowledge, and get started on your cloud native journey, and at least have a clearer idea of the basics, because these are the things that are important in a Kubernetes installation. So essentially, if you want to learn more cloud native fundamentals, we actually have free courses on Rancher Academy to learn more. We as in me and my team, we create these courses so that absolute beginners with no idea of what cloud native is can get started. There's understanding cloud native fundamentals learning path, which teaches you um, YAML if you don't know it. It teaches you container basics. It teaches you Kubernetes basics, and it teaches you in a stepwise progression. You don't need to do all the courses, but if you don't know anything, this is a great place to start from. And also more resources for you all to check out. In case you are interested in contributing to the Kubernetes project, we're always in need of contributors, whether it's in the code or on the non-code side. So we welcome everyone on the Kubernetes Slack. Documentation, as always, is also a huge part of the project success. So if there are any interested parties in contributing to the documentation, go through the documentation and see if there are issues that you can pick up from like a beginner perspective. It's very crucial to us that we make the documentation accessible and inclusive to everyone, including beginners and people who have no idea of what Kubernetes is. And if you are interested in trying out our project and my company's projects, they're all open source. And if you want to give feedback, or if you're stuck at a particular issue, we recommend you join the slack.rancher.io link. That's also here. And specific to Rancher Desktop, we have the documentation link here. And with that, thank you so much for all your attention and time. I really hope you'll have gained something from this. And I'm open to any questions if there are any. Otherwise, have a great rest of the event.